right, now we're going to actually jump into it. So first thing we want to do is focus on the single family stuff that's changed. What's really changed is the number of energy credits since the 2015 code. The medium dwelling units, the code is based on the size of, you need to have more energy credits as the home gets bigger. So we're going to concentrate on examples for the medium-sized home because that seems to be the most frequently used home. And then the size, and we're talking there about 3.5 credits. Now we're up to 6 credits, and depending on the fuel that's chose for the primary heating system, you may actually need 6 to 7 credits. Next slide, please. And the fuel normalization is the new thing that addresses some of the climate parameters. This is where we get into looking at the energy implications on the climate and carbon dioxide into the atmosphere as a result of space heating. So this is new to the code and is really challenging, and we're learning every day about opportunities and challenges with implementing the fuel normalization credits. What this means is that if you're building a home, you have to look at what is the primary heating system type, and then you get characterized as type 1 through 5. And there's different energy or fuel normalization credits that you have to decide which ones you're going to take. And what it suggests here is that system type 1, that would be like a combustion heating equipment, a gas furnace. And there, if you put in a gas furnace, you get 0 additional fuel credits. You don't get any less, and you don't get any more. If you then went to system type 2, this would be a heat pump, just a standard heat pump, no high efficiency level, just that you put in a heat pump and that heat pump is producing efficient space heating energy savings. And this is something that is really going to be important as a transition. I think we're going to see more and more builders going to heat pumps and shifting away from combustion heat because you get a full credit towards that. Now, if you go to a heating system based on electric resistance heat, whether that's baseboard or electric furnace, now you're having to make up a credit because it's a -1 credit. And if you put in what we call a hybrid system where there's a mini split in the main living area of the home, and the rest of the home is heated by electric resistance heat, like a ductless mini split, and then say baseboard or electric resistance in the other bedrooms, and then you'd get a half a credit, not the full credit that you'd get with the heat pump that's serving the entire house. And then for all other systems, that would be -1. And if you run into something that's you're not sure on the all other, that's where we're still breaking trail. But -1 is something that is going to make it more challenging to get your energy credits. Next slide. So why did they do this? Why is it that we're having to now choose and define the space heating primary system as part of the energy code? Well, the fuel normalization credit challenge is really based on some realities. This is a slide here that shows the price drop in solar electricity and wind at the power plant level. So what we're looking at is you burn gas in a furnace at the site and how much carbon goes up in the atmosphere. If you have a heat pump that's doing the same thing on that site, this assumes that all new generation in our state, and there's laws that they're moving in that direction, are going to be done with wind or solar because the price is down and is very competitive, if not below what it costs to do more conventional power generation. So this is how we convert based on the fact that future generation is going to be mostly renewables. Then there's benefits of using an efficient heating system on site from an efficient renewable generation facility. So that's what we're talking about here and the logic behind moving to fuel normalization. And again, there's 2 things going on. We're trying to reduce the cost of consumers, but we're also of energy and their operating costs, but we're also looking at the climate. And those are things that I appreciate. If you're interested in, let's hold off on those discussions and focus on the technical today. And we can direct you to where the research and the background on all these initiatives are at the State Building Code Council. Next slide. So as you get into the energy credits, you're going to see that there are different categories, like they were in the last code, that you want to decide. You need to pick from not all the categories, but you can pick basically one from each category. There's one exception in water heating. But here's an example of two of the categories. The first one gives you a lot of different options for energy efficient envelopes. And then another one highlighted is build tight, ventilate right, where you build a tighter envelope. And you put in higher efficiency ventilation. Next slide, please. And here's an example now of options 3. These are more efficient heating systems. So you could get an energy credit for putting in a minimum efficiency heat pump, and then get additional credits if you build that heat pump more efficiently. And that's one option, more efficient gas furnace, ground source heat pump. There's a lot of different options here. Next slide. We'll get into these. And then another option, and this is kind of the most cost-effective, low-hanging fruit that I've been talking about for about 20 years, and it's finally making it into the code. You know, if you buy all this expensive HVAC equipment and you put it in your home and you put your air handler in the garage and you put your ducts up in the attic, and the attic's a vented attic, so it's like being outside, and you put your other ducts in the crawl space, and that's a vented crawl space, so it's like being outside. You have losses. So every time you put a BTU out of that furnace in the garage, maybe only 70% of that actually gets to the house, and the other 30% is lost. So you buy an expensive state-of-the-art HVAC system, and you're losing a third of the heat out of it because you haven't paid attention to the location of the ductwork and the thermal distribution system, or you haven't paid attention to good quality insulation, or both. So this gives you credits if you move the entire system in a conditioned space, or another credit for a buried duct system that gets the air handler in the conditioned space and some of the ducts buried in the attic. We're working on some other options and flexibility. So anyway, those are two credits that I'm going to talk about quite a bit, and they are the most cost effective, but they're the biggest pain, because you got to sit down now and go back to each one of your plans if you're a builder and re-engineer it. And this is something that won't happen if your architect and your builder and your heating contractor all haven't sat down beforehand. So I will get into this quite a bit, because if you want to get the most cost-effective way of achieving these new codes and these energy credits, you got to do this. You got to bring the HVAC guy in early on in the process. The next is energy efficient water heating, and that would be going to a higher efficiency, like condensing gas water heater, or a heat pump water heater. And we'll talk about that too. There's a big transition to heat pump water heaters from electric resistance, and a lot of energy credits for it. Next slide. In addition, we have renewable energy credits if you put PV on the roof, up to 3 credits. And we have a new series of credits for more efficient appliances. And the real game changer there is the dryer. It needs to be a ventless dryer to get these credits. And that's something to get into, a new emerging technology. The nice thing about the ventless dryer is you don't have to worry about a vent. The challenge on the ventless dryer is they're a little bit more expensive, and we got to see how the market accepts them.